All right, in that case, let's go forward now and look at the solution to the lab problems. So these are problems that you need to complete in lab or at home and submit those as a lab in the form of a lab report. So let's take a look at the first one. It's 6-7. So I went ahead and I created a project for 6-7. It's a console application. I created a console application and I copied an earlier console application just to get the project started. So 6-7, write a predicate function bool equals a vector int A, vector int B. So write a predicate function that checks whether two vectors have the same elements in the same order. All right, let's do that. A predicate function. So it's telling us I'll just do this. Let's make sure that this builds. Okay, there's the OK. So it's a predicate function that checks whether two vectors are equal. Is that what it looks like? Equals? Equals. So it's a vector of int A. Didn't do that right. Vector of int A, vector of int B. And that returns a bool. Let's stub it out. Let's just return true. Oh, what's the problem? Yeah, include vector. Good, thanks. Got to get that in there. See if that builds. That runs. So now what we want to do is we want to test this function equals. And it returns true if the two vectors A and B are equal, and returns false if they're not equal. So we'll do something like this. We'll create two vectors. We need to test them. So we'll do something like this. This is test 1. Just test 1. It's a vector of int. We'll call it A. And then we'll push back, say, -1. And then vector of int B, and we'll push back the same values. They should be equal in every way, right? Same elements in the same order. So this should return, if we want to check A and B, this, when we call equals on them, they should return true. I'm sorry, this is B. So we construct two vectors, A and B, and there we go. So we're just returning true here. So we haven't implemented equals. We're going to do test first development. We're going to write our test cases first. And then we're going to implement the function and see that the test cases succeed. So this is an example of test test first development. So A equals B, it prints 1. I wanted to print true, but it prints 1. That's okay. So equals returns. So if we print a bool, it returns 1. We could do it like this. That's okay. Leave it like that. If we were to return false, what does it look like? Looks like a 0, I think. Yeah. Right, that's the output operator. That's how they implemented the output operator. When you pass a bool into it, it prints 0 or 1. Okay. So let's go back, return true. There's another way of doing this. Well, before I do that, let's do test 2. And let's create a vector, 2 vectors C and D. This is C, and this is D. And let's just put these in different order. They have the same elements. So this should be false, right? This should be false, which is 0. And this is this should be true, which is 1. Well, once again, it's one of the problems with test first programming is that you have bugs in your test code. So let's just see, we're catching those. A equals B should be 1. A equals B should be 0. But there's a cleaner way of doing this. I want to show that to you. It's called using assertions. So this is our test case. We create a vector A, we create a vector B, and then we assert that A equals B returns true. Now assert is in a header called CSUSB. So the assert function takes an expression that evaluates to true or false. And if you pass true into assert, nothing happens. Execution just quietly continues on. But if you pass false into assert, then assert will terminate the program with an error message. So in assertion, it's saying this expression, the expression you give to me, is true. And if it's not true, there's something wrong with my assumptions. So there's no reason to continue. There's an error in the logic. I'm not going to go beyond this point. So this is an assertion. But that's okay. This is the second one. We didn't convert this to an assertion yet. Let's convert that one to an assertion. Here, when we call equals on C and D, we want equals to return false, right? So we don't want to assert that equals. We want to assert that equals returns false, just like we want to assert that this returns true. The other way to do that you might see this, you would see the other form. You could just, instead of saying equals equals false, you just say assert that not equals. Because this this would be this expression here. If we design the equals function correctly, this will return false for C and D. And then when we apply the not operator, it'll convert the false into a true, and then we're passing true into assert. Now it's like this up here. We want assert to return true here. So we just pass, you know, the expression into assert. These commented out forms of that assertion, that's how I would do it, because, you know, I do this a lot. So, you know, I wouldn't do this. So maybe I would actually, because this is easy to read, isn't it? This comparison, this is easy to read. Maybe it's easier to read. Maybe I would use that instead. Well, these are alternative forms. I'm just going to take those out just to make it easier to look at. So equal should return false in this case and true in this case. So if we run, this assertion is now going to fail because we haven't implemented the function yet. We're just returning true. So this, even though these two vectors should be unequal, when we call equals, it still returns true incorrectly. So let's see what an assertion looks like. Oh, there it is. Debug error. Abort has been called. And then you can see in the console window, assertion failed equals CD equals false. And it gives us the file, and it gives us the line number. So the assertion function gives us a lot of useful information for debugging. So when you write big programs, it's very helpful to include assertions, because assertions help you catch logic errors. So you can be actually very liberal about assertions. And here's the other thing about assertions. Suppose you're writing a video game and you don't want slow code. You want everything to run really quickly. You know, when you call an assertion, it consumes CPU time. So especially if you're in like a simulation loop that's running really quickly, you just keep calling assert all the time, you're spending a lot of extra time on that. Well, you don't have to worry. You can leave the assert in there, because when you go to say publish your game or to give it to a customer, you're not going to do a debug build. You're going to do a release build. And when you do a release build, the assertions are omitted by the compiler. See, it shows it right here, the debug library. So this won't even work with a release build. You know what? Let me test that. I said that, right, like an authority. But on the inside, I feel like, wait a minute, have I ever really fully tested that? Let's test that. Let's look at that. Let's go into, let's just see what I just said is true or false. Let's set the configuration to release. And this shows release here. I don't know why it shows debug up here, so I'm going to change that to release. Just to make sure it's going to be set on release. There it is. So we're rebuilding everything. Now this is called a release build. Everything is failing. You know what? The author's libraries, maybe they don't build correctly, but our console application probably built all right. So let's just check that. Let's build just our application. That one's good. All right, let's run it. See, okay, we don't get the assertion. because we did a release build. So the assertions are omitted from the compilation. I better set everything back. That's right. Okay. The setting is not there. The setting was up here. Let's see if we are restored. There it is. All right, now let's implement the function. We need to return false if the two vectors are different from each other. So here's an automation problem. How do we check that the two vectors are equal to each other? Does anyone want to do this? Anyone want to make a suggestion, or should I just type it up? Well, you'll do this on your own at home or in lab. I'll just type it up. Okay. There's a lot of different ways to try to tackle the problem, right? Now I'm just thinking, let's do it in 2 stages. Let's first check to see if their lengths are the same. If their lengths are different, they're not going to be equal. So let's do if a dot size is not equal to b dot size, what do? We return false. We know that the vectors are not equal. But now, at this point, we know that a dot size is b dot size, so we can do a loop for integer. Let's do unsigned int. For unsigned int I is 0, I is less than a dot size, or it could have been b dot size because they're the same thing. We know that at this point. And we test if a of I is not equal to b of I. We know the two vectors are not equal. We're going to return false. One more line to put in there. Anybody have a suggestion? There's one line more that needs to go. You know? What would you do, Mike? Return true at the end, yeah. At this point, at the very end, we passed all of our checks. There it is. Everything is good. And we might want to put in some additional tests, like these tests are inadequate, because what happens if you had omitted this? Let's suppose you omitted that logic there. That's necessary logic, right? That necessary logic, we're okay. We're okay. But look at this. This is incorrect. And we can create a test case that shows that code is inadequate. Let's do that right now. So C and D, all we need to do, leave those the same, just add another item to D. Now C and D are different, but C and D agree in the first 2 slots. And when we do this loop, we look at the size of the first argument, which would be C. So we're only going to check 2 slots. Nope. A redefinition, sorry. This should be C and D, so that's E and F. This is E, and this is F. Says okay, but they're different. They should fail. So then we have to go back and say, all right, our first two tests were good, but they were inadequate to check for completeness in the problem, because we had forgotten to check or failed to check for this condition here, that the two vectors are the same length. There are other ways to implement this solution, by the way. This is just one way. Oh, what happened? How come that worked? C and D are unequal, right? Oh, sorry. I totally screwed that up. Sorry. Let's put this back in here. We didn't check this. We'll make this 4 and 1, and 4 and 1. All right. These are now equal in the first two slots, but F has an additional data item. So this should return false, but it ends up returning true. So this assertion will fail. There we go. So that means this code is needed. There we go. So when we're writing this code here, it's, what we're working on here is we're also debugging and thinking about the test code as well. All right, that completes 6-7.